Today we're finishing up our YL620-A VFD installation, but don't think of this as a sequel so much as a reboot, so don't worry if you haven't seen the first video. Installing a VFD in an enclosure means some of this, a lot of this, and a fair bit of this, and here is the result. I know it's slightly scruffy, but at some point when I'm going away for a weekend I'll tear it down and give it a nice fresh coat of paint. You don't need me to hold your hand through making a few holes in a metal box. Essentially you'll need an angle grinder for big squarish holes, a set of hole saws for medium-sized round holes, a step drill for smaller round holes, and a punch for marking your hole centres. And while you're at it, grab a handful of cobalt drills in the sizes you need. They're way better for drilling steel than HSS. You don't need a grinder this big. You can do just as well with a Dremel and some patience, and you're less likely to melt your paint like I did. When it comes to drills, the hole saws do work, but the step drills work better. So if you can afford a step drill in the size that you need, then that's the way to go. But once you go beyond about 30mm, the price goes up quite steeply. As for cabling, a set of cheap wire strippers like these will make your life much easier. And here we have a crimping tool for insulated crimps like these. Now I've used these ring crimps for most of the installation. However, you would be better off with forked crimps for the connections to the VFD, the emergency stop, and the direction selector switch. And 6mm ring crimps for the earthing points in the enclosure, and you want spade crimps for your on and off switches. Anyway, back to the enclosure. Power is fed into the enclosure via this flex and through a cable gland. The gland we're using is one of these. It fits a 20mm knockout or hole, and the cable is fed through this 20mm nut. In a real world scenario, bear in mind you'd be feeding this through the nut, so for the purposes of demonstrating this, I can put it on the other end. I just snipped a bit of cable off. And we've got a plastic washer, a rubber grommet, and then the whole lot goes through the gland. That rubber grommet pushes in, fairly fat cable for that grommet. It all tightens up, and that provides a nice seal and I'd say a little bit of strain relief for the cable, but I wouldn't push it. I'd rather have some strain relief inside the enclosure. There's also a socket for the 3-phase motor plug. This is optional in that you can wire your motor directly to the VFD, but if you do ever have to remove either of them, this will make it much more convenient. If we look inside the enclosure, you'll be able to see the 2 cable entries and the clearance holes drilled into the enclosure mounting plate for them, as well as a ton of control cabling. Our 240V in goes to the first 2 positions on the black terminal block, with 3-phase out occupying the next 3. That's UV and W, or L1, L2 and L3, depending on how your equipment is labelled. The last 3 terminals are for an earth cable and braking resistor, the values for which are listed in the manual. Unfortunately I don't have one to show you, but for this VFD and motor combination we'd be looking at a resistor of about 8 inches long, with an almost 2-inch diameter, considerably bigger than the one we have here. And what the braking resistor does is to allow the VFD to bring the motor speed down much faster than allowing it to coast down all on its own. Switches and ancillary equipment are connected to the green control terminals, and for this setup we'll be using a 3-wire control scheme for our start, stop and motor direction selector switches. The negative terminals of our control switches will return to X ground, which is why it's a good idea to have a set of terminal blocks like these mounted on a DIN rail inside the enclosure. To set up our 3-wire control system, you need your stop switch wired to terminal X4 via the normally closed contact on your switch, and then to X ground via the contact blocks. The direction selector switch is wired to the reverse terminal. When that contact is closed, the VFD will run the motor in reverse, and when it's open, the motor will run forward, so you only need a single pole, single throw switch for this application, making the one we have fitted a little bit overkill, but it was scavenged from some old hardware and I really like the way this type of switch feels. The start button is wired to the forward terminal, but this time you're connecting your cable to the normally open terminal on the switch. And that's our basic wiring setup complete, and if you didn't quite catch all that, then there is this wiring diagram, which I'll also link to in the description. Now we need to program the VFD according to the table here. Again, this will be linked in the description. So to select a setting, press the program button on the VFD, and once you are in programming mode, the display button will shift between the 2 sets of digits and the arrow buttons will increment or decrement the number. Starting with P12 through to P1206, which is here on the table, are the settings for motor current, voltage, poles, no load current and the rated current and voltage for the VFD. The numbers for these should be on your motor faceplate and the VFD faceplate. The next settings are P0004 through to P0010, and P0004 is your maximum output frequency, so this is actually the frequency from your motor. So if you look in your motor faceplate or in the manufacturer's literature, if you've got something fancy, then you'll find the frequency for your motor. Now I'm running some fairly standard 3-phase AC motors. They all match the mains frequency here, which is 50 Hertz. So, you know, that's 50 Hertz, and that'll be matching your motor. The maximum output voltage frequency, again, these are slightly badly named because actually this is the maximum output frequency from the VFD. This is the one you want to modify if you want to either over or underspeed your motor, or at the top end anyway. So if we wanted to run our motor at double the speed, we'd set this at 100 Hertz. There is also a minimum, which is down here. So this is we'll go through the middles and the minimums in a second. But you've also got your maximum output voltage. And that's between 10 and 150%. I've got that set at 100% for the moment. But that's all about the torque curve, and that's really what the next lot of settings are. So you can run your motor at 100% all the time, but one of the nice things about having a VFD is having speed control. So you have a middle frequency, middle voltage, minimum frequency, and minimum voltage. And you can set, for instance, your minimum frequency, and I'll set that down to 3 Hertz. I'm going to double check that because I'm pretty sure I set that a little higher, but the middle frequency is 25 Hertz, and this forms a torque curve. Now, the manual for this VFD doesn't really go into that, so I'm going to link to a manual for HY VFD. It's the one that I use for the lathe, and that actually does go into detail about a lot more of these settings. Unfortunately, the setting offsets don't match up. But if you have a flick through that manual, it'll give you a better idea of what a lot of the settings actually do, especially some of the more obscure ones. Whereas the YL620 manual it's a bit sparse on detail. I think they kind of assume that you know roughly what you're doing. So I'll post that in the description so you can have a look through there and get a better idea of what's really going on. So related to these settings, or in particular related to P0005, is P0024, sorry, P0023, and P0308 and P0309. So P0023 is the display frequency to RPM multiplier, and what this does is, this tells the VFD what you want it to display when you turn the speed controller, the little potentiometer on the front. And this is a ratio, so you want to take your RPM, and that's going to be the RPM of the motor, or the RPM of whatever the shaft is, the output shaft is, take the RPM of that if possible. So I'm using this on the milling machine, this will be for the mill. And on the front of the mill there is a plate, and that has the RPM for the different combinations of pulleys. So I put that right in the middle where I know it's one-to-one with the motor, so it's 1440 I think, or 1420. And I can sort of roughly work out what the rest of the settings would be from there. But generally speaking, you want that to be your, whatever your output RPM is, not just the motor RPM. I've divided that by the maximum frequency, so that's P0005, and then multiply it by 10, and that gives you your ratio. Now, this doesn't display more than 4 digits, so if you do have, say, a 10,000 RPM motor, you'd set it to 1,000 RPM, and you'd kind of have to make a mental note to add the 0. Unfortunately, but you can't get it to display 5 digits. But there's another user found that in the comments on the last video, so it's something useful to know. Anyway, P0308 and P0309 are the panel potentiometer minimum and maximum frequencies. And so, like I said, this is about displaying the actual RPM. So this is just the frequency. So you want to set that in line with your minimum and maximum here. So P0005 would be your maximum, and P0009 would be your minimum. And yeah, this will display your RPM, which is pretty cool. But if you are going to run your motor either over or under its rated frequency, you kind of have to be careful with that. It's something you want to play with, that's fine. But some motors won't like being undersped because you won't get enough airflow over if they got a cooling fan attached to the spindle, they won't get enough airflow over the casing. You'll end up with an overheating motor, or you run it over speed and you end up with an overheating motor. It's something for you to decide whether you want to do that or want to try it out. I haven't really found it to be a problem in practice, but you know, I'm not running machinery for hours at a time. It's 10-15 minute bursts, and they've got half-hour cool down. Also, if you have anything attached to a spinning shaft that you're powering with a motor and you're playing around with those settings, especially braking settings, just take everything off there. Anything that can come off, like a chuck or a collet, something like that, just take it off, put it to one side. I have had, I was playing with the speed on the lathe, and I've got a threaded spindle nose. So when I hit the off button, the braking kicked in. But bear in mind, I was running the lathe at about 2000 RPM, which it's not really supposed to run that quick. The braking kicked in, the spindle stopped, the chuck didn't, unscrewed itself, slammed into the bed of the lathe, bounced across the room, and stopped when it finally hit the wall on the other side of the workshop. So the lathe is on one side, is actually up against the wall on one side, and it actually rolled, you know, 20 odd foot into a wall on the other side of the shop. So just be careful, you know, don't get in the way of anything, take anything loose off, just be careful with it. And if you have, if you're lucky enough to have a manufacturer's recommendation to fall back on, that's great. So I know that some of the spindles that you can buy, like the like I mentioned earlier, the water cool spindles or the CNC spindles, have quite detailed manufacturer's recommendations for all of these settings, and for more actually. This isn't really going into that kind of detail. But if someone wants to chuck a spindle like that at me, I'll happily go through and do a setup. But yeah, if you look at the HY VFD manual, that actually has that in. That came from a CNC, I guess retailer, and that had some really detailed settings for how to set up that kind of spindle, which was less relevant to me, but it's, you know, kind of handy to know. To enable 3-wire control mode, we're going to start with setting P0001, which needs to be set to 1. Now this enables external control of the VFD. In this mode, the start button on the VFD control panel becomes inactive, but all of the other buttons, including the stop button, should remain functional. And then we need to change P0016 to mode 2, which enables the 3-wire control setting. And now we can hit the big green button to test the motor. I do like to have a visual indicator of whether the machine is stopped or is supposed to be running. And the VFD has a single pole dual throw relay, which can be actuated under certain conditions, which are listed in the settings section of the manual or on the spreadsheet I have here. As is going to activate when the motor runs and deactivate when the motor is stopped, sending power to either the green or red switch LEDs. For this we'll be using the common NC1, NO1, ground and 13 volt terminals. And first we're going to jumper the 13 volts to the common terminal. Then, having checked the LED polarity with the diode tester on the multimeter, we'll attach the wire from the positive side of our red LED to NC1, with the negative side returning to ground. The green LED is the same, but with the positive side connected to NO1. The last thing to do is to set P0403 to 1, and that governs when the relay actually activates, and 1 is if it's running, then the relay is on. And now we'll get a red light when the VFD is off, and when we hit the run button, the green LED will illuminate, indicating that the motor is supposed to be running. And with that, we're all done. So this is just a basic setup that should hopefully get you up and running with something like a milling machine or a lathe or, you know, pump motors, that kind of stuff. But you might find that there are other settings you need to alter for your specific motor or spindle, like I said earlier. And for that, hopefully you'll have access to your manufacturer's materials, manuals, literature, that kind of thing. Or alternatively, you can, you know, post a comment, ask for help, see if someone's got the answers for you, or, you know, I'll dive into the comments and see if I can help out. And you know, as usual, I'll do my best to answer any questions as best I can. So I hope that the linked materials in the description will be useful as well, and that this video has helped you out. And yeah, I'll see you in the next one.